Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, today's lessons we will look at binomial distributions. Right, this is from AS Statistic 1. Okay, a discrete random variable X is said to have a binomial distribution and is defined by its two parameters N and P. The details are listed in the table below. So when we define a binomial distribution, which says that the variable X follow binomial distributions, and we put down the parameters, small letter n and small letter p, right? So how do we know a particular exam question is talking about a binomial distribution? We look for these conditions or the criteria. Okay, first one, it has n repeated independent trials. Second, constant probability, which is small letter p. Okay, that means the n, small letter n, represents the independent trials. The third one, only two possible outcomes. And the fourth one is the fixed number of independent trials. Okay, or it's also the number of trials are finite. Okay, so the conditions are very similar to geometric distributions. So the main difference is the point number 4. For binomial distributions, it has a fixed number of trials, whereas the geometric distributions, well, the number of trials can be infinite. Okay, so to calculate the probability for binomial distributions, we have the formula, and which is given in the formula list. Right, MF19 formula list. If we are finding the mean, the E of X, so which is the mean, sometimes the question might use the word average. So it's given as this simple formula NP. So as well as the variance. And the formula is MP times 1 minus P. And these are also given in the formula list MF19. So now we will look at example 1 to see a few situations that are appropriate to model as a binomial distribution. Okay, so we look at the example 1A. A coin is biased so that the probability that it will show heads on any throw is 2/3. So there is a probability given, 2/3. And in other words, this is a constant probability. Okay, the coin is thrown 5 times. See, this is the fixed number of independent trials, which is small letter n. So 5 times. Okay, the random variable X is denoted as the number of heads obtained. So which means we randomly throw this coin 5 times and we are finding the probability. Let's say, what is the probability that the X equals to 2? What does it mean by this? It means that out of 5 throws at random, the probability that we get hit, there are 2 throws out of 5. Okay? So this is a binomial distribution with the parameters n is 5 and the probability 2/3. So now we have a look of B. There is a 15% chance of rain on any day during the next 14 days. So in this sentence, we are given the 15%. So in other words, there is a constant probability, which is 0.15. Okay, and the second info, the 14 days. It should be the independent trials, 14, and it's a fixed number of trials. Okay, so if the variable R as the number of rainy days during the next 14 days, so which means R can be modeled as a binomial distribution. All right, so that's why I will write down as this. The capital R follows a binomial distribution, capital B, and the parameters are 14 days, and the probability on any day that will be raining is 0.15. Okay, so that is how you determine whether a particular question is talking about binomial distributions or not. You look for these information, which is independent trials and constant probability. All right, now we have a look of C. In a certain country, on average, 1 student in 5 has blue eyes. Okay, so this sentence is actually giving you the constant probability. How do I know that? This sentence, on average, 1 student in 5 has blue eyes. So it's actually telling you the probability for the student to have blue eye is 1 out of 5. Okay, so this on average. This is the keyword. When you're given a sentence like this, on average, 2 out of 5 or 3 out of 10, and so on, that is telling you constant probability. So for a random selection of 7 students, so you can see that a selection of 7 students at random is actually giving you the independent trials, and it's a fixed number of trials, which is 7 here. Okay, X is denoted as the number of students who have blue eyes. So with these two information determined, the P is 1/5, the N is 7. We know that this variable X follows binomial distributions with the parameters 7 and 1/5. Okay, so that is how you see a particular question and determine the N and P so that you can use the binomial distribution formula to find out the probability later. Right, now we look at example 2. So you can tell that this is the example 1B, right? There is a 15% chance on any day during the next 14 days. Okay, so since I have explained that the capital R follows binomial distributions where the N is 14. And then the probability for any day to be raining is 0.15. Okay, now we're trying to find out the probability. Find the probability that there are exactly 3 rainy days. So what do we need to do is to find out the probability of R, capital R, which is the number of rainy days during the next 14 days, right? And it has exactly 3, which means out of 14 days, what is the probability that there are exactly 3 rainy days? So you must see that the rainy day out of 14, it can be the first 3 days that are raining, or it can be the last 3 days that are raining, right? Or it can be any 3 days out of 14 days that are raining. So in order to find out the probability, we use the binomial distribution formula. Okay, so I will write down the formula at the side here. So in the formula list, MF19 is given as this, capital P, the probability, and the R, right? Then NCR, and then the P to power of R, at the same time 1 minus P to power of N minus R. Okay, so we are using this formula. That means when I write P bracket R equals to 3, it actually means P 3, right? So the small letter R is 3 here. So by using the formula, the N is 14 and R is 3. It means 3 days out of the 14 days, any 3 of the 14 days, right? So it's given by 14C3. And the probability is 0.15. And then, so to power 3, because occur 3 times. 1 minus 0.15. And then the 14 minus 3. So using the formula, you should be able to get the probability. Okay, simplify a little bit, which is 0.85. And then 14 minus 3 is 11. Now we can use calculator and find out the probability. 14 right, is going to give you 0.20558. So if we round up to 3 significant, 0.206 as the answer. Okay, so that is the answer for part A. So now we are answering part B. So what is the probability here? So again, in the beginning, when we read the first sentence, we can tell that, oh, there is a constant probability and there is a fixed number of trials. So this is a binomial distribution. And then we are trying to find the probability that there are at most 2 rainy days. So we are trying to find probability that the capital R, number of rainy days, is at most, like less than, equals to 2, at most 2 rainy days. And what does it mean? It means that out of 14 days, it can have no raining day at all, or it can have exactly 1 raining day, or 2 rainy days, right? Then we are going to use the formula 3 times and find out the probability for this, at most 2 rainy days. Okay, so we're going to use the formula for R equals to 0. So we have 14, C0, 0.15 to power of 0. And 1 minus 0.15 is 0.85. Then to power of 14, right? So plus for R equals to 1. So do the same thing. And plus with R equals to 2, 14C2. Okay, then we press calculator to find out the probability and getting the answer. So if you are aware of this, your calculation will be faster. That 14C0 is going to be a 1. And anything to power of 0 is also going to be 1. So for the first term, you can just press 0.85 to power of 14, right? Then plus with your second 14C1, which is 14, times 0.15 times 0.85 to power of 13. Okay, and then plus with the last one, 14C2 times with 0.15 squared times with 0.85 to power of 12. Okay, the answer is 0.6479. So if we round off to 3, okay, change back to blue color. If we round off to 3 significant, so we can put it down as 0.648. Okay, 6479. All right, maybe I write down as 6479 first. 6479. Then 0.648 S3SF. Okay. So why do I do this? Because I need to answer the part C now. Okay. We're trying to find the probability that there are at least 3 rainy days. So to find out probability of at least 3 rainy days, it's going to be capital R, the number of rainy days, at least, like greater and equals to 3. So that means a random selections of 14 days, right? So what is the probability that at least 3 rainy days? Means we are going to consider exactly 3 rainy days, or 4, or 5, or 6, or 7, until out of 14 days, all 14 days are raining, right? So that is the probability of at least 3 raining days. So it's not a good choice that you need to do the calculation using the formula for so many times. So in this kind of situations, what would we do? We will try to take 1 minus the probability that the R less than 3 rainy day. All right. And if that is the case, less than 3, isn't it, is the same as R less than equals to 2, and which is the answer I have found in part B. All right, less than 3 rainy days. That means it will be either 2 rainy days or below. So it's either 2 rainy day, 1 rainy day, or no rainy day out of 14 days. Okay. So the probability that the number of rainy days less than equals to 2, right? Which is the answer I found in part B, 0.6479. So 1 minus, then the answer for at least 3 rainy days will be 0.3521. Right, 3521 round off to 3SF, 352. All right, so that is the part C, finding the probability. Okay, so what can we see is that very frequently in our exam questions, if you are going to use the formula to find out the probability, very common one will be 4 times to 6 times. Like example B, we are going to use the formula 1 time, 2 times, and 3 times, right? This is common. So that means if you are requested to find out the probability using the binomial distribution formula 4 to 6 times in the question, this is common. Okay, if you are required to use the formula more than 6 times, probably it will be like question C, that you can use 1 minus the probability of the other side, then you will get the answer faster, right? Now we have a look of the last part. Find the mean and variance of R. So the mean E of R, which is the expectation, right? And for binomial distribution, we just need to use this simple formula, MP. So we have N14, and then the P is 0.15. So what do we get? 14 times 0.15, 2.1. So based on the info here, we are expecting to have a 2.1 rainy day out of 14 days. So variance, we also have a simple formula, MPQ. So 14, maybe we should write it down as MPN times 1 minus P. 1 minus P, okay? So P is 0.15 and 1 minus P is 0.85. All right, so the variance is 1.785. 1.785. Okay, so if round out to 3 SF, 1.79. Okay, so we found the mean and the variance for this binomial distribution using the simple formula that are given in your MF19 formula list.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.